So this is another lens problem, and now it tells us we have an object that's located 37 centimeters to the left of the lens, and the image is formed 15 centimeters to the right of the lens, and we want to know what's the focal length of the lens. And you notice that here they don't tell us whether it's a concave lens or a convex lens, whether it's converging or diverging. All right, so what do I know? Well, I know I've got my image is 37 centimeters. Let me draw. Here's my mystery lens. I'm going to draw it as a dashed thing. I don't know whether it's curving in or curving out. My object is over here, 37 centimeters on the left side. So that's my DO. And my image is over here, 15 centimeters on the opposite side, on the right side. So DO is equal to 37 centimeters. DI is equal to 15 centimeters. And we know DI could be either positive or negative, right? Because an image can either be real or virtual. It can either be positive or negative DI. So do we know which it is? Well, we know that the object's on one side, the image is on the other side. So for a lens, that's a real image. So I'm going to make that plus. So it's real. Okay. If I were to draw my arrow, how would I draw it? Would I draw it upside right or upside down? Well, we know from practice that a real image, if I have a single lens or a single mirror, a real image is always inverted, and a virtual image is always upright. So since my image is real, I need to draw my image arrow as being upside down. Okay, so what kind of lens is this? Can I guess what kind of lens it is? Yes, I can, right? Because remember, for a diverging lens, it's always going to have a virtual upright image. So since my image is real and inverted, I can't have a diverging lens. It must be a converging lens. So it must be a converging lens. And for a converging lens, I should have a positive focal length. And for a converging lens, my image can either be real or inverted, or it can be virtual or upright, depending on whether my object's inside or outside the focal point. All right, so I know I should get a positive focal length. Is it important that I draw this? No, it's not, as long as I put my numbers in right. So what equation do I use? Well, that same old equation, 1 over f equals 1 over di plus 1 over do. And now I want to find f. I know di and do. So remember, to get f, I need to take 1 over. So f is equal to 1 over di plus 1 over do, and I need to take the reciprocal of that. And now I know those numbers, just plug them in. 1 over 15 plus 1 over 37. We know it doesn't matter which order I put them in. I could have put 1 over do plus 1 over di, right? A plus b is the same as b plus a. So if I do that, I get plus 10.7 centimeters. And even if I hadn't done the logic to find that my focal length was positive, if I just plug my numbers in, I get a positive focal length, and that tells me that it is converging. Okay, so again, if I had drawn a picture, what would I draw? So now I know it's a converging lens. Let me just quickly draw a sketch. So converging lens is fatter in the middle than it is at the edges, so it looks like that. My focal length is 10.7 centimeters. So let me draw it roughly to scale. So there's my focal length. So f is on this side, for f prime's on the other side. And my object is at 37 centimeters. So that's like, what, 3.5 times further away. So let me draw it roughly to scale. There's my object. And let's see, the image is 15 centimeters, so it should be 1.5. But let's just draw it and see what we get. So ray 1 comes in parallel, hits the center axis of the lens, draw a dashed line, and then it bends down and goes out through the focal length. So there's ray 1. The other ray I like to draw is, remember, the one that comes from the tip of the object arrow through the center. You just take a ruler, you draw it like that, and I get my image arrow is where those two meet. All right, so I obviously didn't quite draw my line right. Draw my line straight. My image should have been a bit closer. Let me try and do that again. All right, so because I'm not using a ruler here, I went a bit wonky. So let me try and extend this line straight. That's a little bit better. So there's that's ray 3. You can see that my image arrow is where those two guys meet. I draw the tip of the arrow, tail's always on the line. So I get an inverted image that's smaller than the object, and it's on the far side. And again, that's what my numbers tell me it should be.